Good day everybody. The solution to this particular question is already available. The content maker has provided the solution and it's there on the social media. But apparently I'm going to use a different technique in solving this question. So you can compare the technique that I'm showing versus the technique that is already existing, and you can choose whichever that is appealing to you. So having mentioned that, let me just go on to solve this. We've been given integral 1 over x squared times 4th root of x to the power of 4 positive 1 raised to the power of 3 times dx. We are expected to integrate this. Now what I wish to do is I would like to make the following substitution. I would like to let x be equal to 1 over u, and this can be rewritten as u is equal to 1 over x. So differentiating both sides, this is going to give me du. Differential of 1 over x is going to be negative 1 over x squared times dx. So from here I can rewrite dx to be as, if I were to move this x squared to the left, this is going to be x squared times du. The negative sign can also be moved. So when I say negative sign is moved, it means I'm multiplying by negative 1 both sides. So you get negative x squared times du is equal to dx. So wherever I have dx, I'm going to replace negative x squared times du. So this quantity is going to be, in place of dx, it's going to be negative x squared times the du divided by, I'm not going to do anything with this x squared, just place it as it is. Now 4th root of, in place of x, I'm going to substitute 1 over u. So this is going to be 1 over u. This has got a degree 4. So it's going to be 1 over u power 4. Positive 1. This is raised to the power of 3. X to the power of 2, x to the power of 2 can be cancelled, giving you. So after cancelling x to the power of 2, I can rewrite the available quantity as integral negative du over 4th root of 1 over u raised to the power of 4 positive 1 raised to the power of 3. Right? Now this can be further rewritten as negative integral du over, now u raised to the power of 4 can be taken as LCM. So this is going to be 4th root of 1 positive u raised to the power of 4 divided by u raised to the power of 4, the whole raised to the power of 3. Now I can rewrite this further as integral, with the negative sign out, du over 4th root of 1 positive u raised to the power of 4 raised to the power of 3 divided by 4th root of u raised to the power of 4 raised to the power of 3. Right? Fair enough. This is going to be negative integral du over 4th root of 1 positive u raised to the power of 4 raised to the power of 3 divided by, now this is going to be u raised to the power of 4. This is raised to the power of 3. So I'm just going to place the 3 like this, and this is in turn raised to the power of 1 over 4. So you got a 1 over 4 over here. Now clearly this 4 and this 4 can be cancelled, and u raised to the power of 3 can be flipped, giving me negative integral u raised to the power of 3 times du divided by 4th root of 1 positive u raised to the power of 4. The entire thing is raised to the power of 3. So this is what you have got. Now I'm going to be making a simple substitution for this quantity, and let us go ahead. Because of the page being exhausted, let me take a new page and show you the working. So this is equal to, this is what we've got, right? Negative integral u raised to the power of 3 divided by 4th root of 1 positive u raised to the power of 4, the whole raised to the power of 3 times du. Now what I wish to do is I would like to take 1 positive u raised to the power of 4 to be equal to, say, some t raised to the power of 4. I want to annihilate this 4th root, so that's the reason I'm taking it as t power 4. So differentiating both sides, we get 4 times u raised to the power of 3 times du is equal to 4 times t raised to the power of 3 times dt. 4 and 4 can be cancelled, and you got u cubed times du is equal to t raised to the power of 3 times dt. So in place of this u raised to the power of 3 times du, you can substitute this. So this is going to be equal to negative integral t cubed dt in place of u cubed du, t cubed dt divided by 1 positive u raised to the power of 4 is going to be t raised to the power of 4. This has got a cubic value, cubic power, place that, and this has to be raised to the power of 1 over 4. So clearly this 4 and this 4 can be cancelled. So you get negative integral t cube times dt divided by, this is going to be t cubed here. Clearly t cube can be cancelled, giving me integral dt. Now when you integrate dt you get t, so it's going to be negative t, but my t to the power of 4 is this, so my t is going to be 4th root of 1 positive u raised to the power of 4, right? So this is what you got. But what is my u? Actually we have taken x to be equal to 1 over u, so therefore my u is equal to 1 over x, right? You can refer to the previous part where I made the substitution. So this is equal to negative of 4th root of 1 positive, u is 1 over x, so it's going to be 1 over x to the power of 4. Now this is equal to negative of, if I were to take the LCM, this is going to be x to the power of 4 positive 1 divided by x to the power of 4. I can rewrite this as 4th root of 1 positive x to the power of 4 divided by 4th root of, so I'm going to write this in this fashion, x to the power of 4 raised to the power of 1 over 4. Fair enough, right? I can always write it like this. So 4 gets cancelled, giving you negative 4th root of 1 positive x to the power of 4 divided by x, because we are taking the 4th root in for x to the power of 4, and we need to place the arbitrary constant c because it's an indefinite integral. So this is the right place for us to stop, and this is the solution for this question.